right, good morning. Today we are adding and subtracting polynomials. Our I can statement is I can add and subtract polynomials. Yesterday we talked about standard form is when you write an expression in descending order according to its exponents. So that's like from high to low. We learned about the leading coefficient. That's the number in front of the variable with the highest exponent. The degree is the highest exponent. No matter what order it's wrote down in, it's always going to be the highest exponent. We can identify or classify polynomials based upon their degree. And remember, the degree is the exponent part, whatever the highest exponent is, or according to the terms. When you talk about terms, remember, terms are separated by plus signs and minus signs. So if you're talking about the highest exponent is 0, that's a constant. That's like the number 4. The exponent of a 1, which is understood to be there on a letter, that's what we're talking about on a letter, is linear. 2 is quadratic, 3 is cubic, 4 is quartic. If you're classifying it according to the number of terms, 1 term is a monomial. 2 terms is a binomial, like a bicycle has 2 wheels, so a binomial has 2 terms. 3 terms is called a trinomial, just like 3 wheels is a tricycle, so you have that tri part as your prefix. And then 4 terms or more, that's why you got that plus sign there, is called a polynomial. Poly just meaning many. So this example right here has 3 terms because it's separated by plus signs and minus signs. Remember, the plus and minus signs go with the term after it, so that's why I've highlighted it 3 different colors. The 3 is the highest exponent because this one has an exponent of a 3. This variable has an exponent of a 1, and this one does not have any exponent because this -3 is called a constant. The +7 is called a coefficient. And the 9 is the leading coefficient, because remember, leading coefficient goes with the variable that has the highest exponent. This, if we were to name this example right here, I can name it 2 different ways. The first way, according to its exponent, according to the degree. The highest degree is a 3. So if I look at my degree list, a 3 is a cubic. And according to the number of terms, there's 3 terms, so 3 terms is a trinomial. Remember, when we are adding and subtracting, you are only just combining like terms. But what is a like term? Remember that like terms have the exact same variable parts. So they have to have the same variable as well as the same exact exponent. So we are going to add polynomials. To me, that's the easiest thing that we're going to do today because all we're doing is adding like terms. And remember, when you're writing down your answer for any polynomial, when you write down your answer, you always start with the highest exponent because you want to write your answer in standard form. So you always start with the highest exponent. Looking at this first example, I have already highlighted my like terms. So the thing that's like 6b cubed would be -4b cubed. 3b squared is like 4b squared, and -2b to the 4th is like -4b to the 4th. When looking at all of these, there's a plus sign in between my 2 trinomials, in between this group and this group. That's why I circled it. That's what the important part is there. Starting with the highest exponent. The highest exponent is my green ones because they have a 4. So I would just type in Desmos. My pink paper is what I'm going to type in Desmos. Let's get you out. I would type -2, and then there's a plus sign there in between the 2 trinomials, and then -4. What is -2 plus -4? When you type it in, it will give you a -6. So I leave my variable parts alone when I go to write down my answer. That would have given me negative 6v to the fourth. The next highest exponent for me is my yellows. It's the v to the third. And if I type it in Desmos again, I have a 6. I'm typing my coefficients in. 6. Then there's a plus sign. And then my other yellow was a negative 4. As I type that in, 6 plus negative 4 is a positive 2. Okay, so that would give me a positive, that's where the plus sign comes from, 2v cubed. The last one that we would do is the orange ones, the exponent of a 2. So I have a positive 3, my plus sign that's in between my two trinomials, and a positive 4. And 3 plus 4 is 7. That's where the 7 comes from. So I can't just write 7. I have to put a positive sign there. So 7b squared. Now I do not have any more like terms because I've already combined them. That's how I know when that's my answer. So now looking at it, I can identify the degree. On this one, the degree is your highest exponent, and my highest exponent is right here. It's a 4. So down here on this blank, it was degree, and you're going to say 4. The next one is your leading coefficient. My leading coefficient comes from the exact same term as my degree. So my degree was 4. I'm looking at this term, and that leading coefficient is the negative 6. The next line says other coefficients, and that other coefficient is other numbers that are in front of letters. So that would have been a positive 2 and a positive 7. I'm going to add another line here. We have a line for name, but I want you to write in the word terms. And on that one, I want you to look at the answer of this and tell me how many terms are there. So this is, let me highlight them so you guys can see them. This is one term. This is one term. And this is one term. I don't know if those colors match, but you get the gist of it. So there are 3 terms here. So that's what I'm going to use when I'm naming my polynomial. Let's first look at the degree. It's got a 4. So 4 is quartic. So on the name, I'm going to write quartic. And it has 3 terms, which is what you told me. So 3 is called trinomial. So a quartic trinomial. Now, this is how we are going to do these. That's the horizontal method. Let's go ahead and try example 2 on the horizontal method, and then I'm going to come back and show you the vertical method. In my opinion, the vertical method gets a little messy. That's why I like the horizontal method. So on this horizontal method 1, I want you to take your yellow highlighter and highlight the 2r cubed. It's just my first number, or my first term, I'm sorry. Is there any other term that's like 2r cubed all the way through this line? And if you look, there's not one. There's not another r raised to the 3 exponent. So then I'm going to highlight the next term. So that one is a negative 1r. You can always write down that 1, just fill it in because it's understood to be there, in between the minus sign and the r. Now, what is the other like term? It's the 8r right here. I'm going to highlight that one. Notice I've already circled my operator that's between my two trinomials, because that's going to be super important, especially when we get to the negative or the minus ones. So looking at this positive 5, just because it's the next one, is there anything else like that positive 5? The negative 8. Very good. The negative 8 is like it because neither one of them have like terms. Or I'm sorry, back up. Neither one of them have variables. So that's why they are like terms. They are also called constants. Right? Now, the only one that's not highlighted, and I just don't have another color highlighter, so I'm just going to leave it white, is this plus 7r squared. All right? So now the next, in order to add the two polynomials together, we're going to look for the highest exponent. So as you look through this entire list, right through here, do you see that the highest exponent is a 3? So now I'm going to write that down. The 3 had the 2r cubed. That's what I'm going to write, 2r cubed. What is the next highest exponent as I look down my list? Got this one done. Next highest exponent is a 2. So I'm going to write that one down, and it was a positive 7r squared. Keep going down the list. And the next highest exponent, because I said 3, 2, that would be a 1. And remember, those 1s are understood to be there. And that means it's my greens. They're understood there. So negative 1r plus 8r. So what you're typing in Desmos is negative 1 plus 8. So what is negative 1 plus 8? 7. Very good. So that's a positive 7, which is where that plus sign comes from. And don't forget, you have to have the r that hangs out next to it. And then last, but definitely not least, is my oranges. And when I type that in Desmos, I have a positive 5, my pink plus sign, and then I have a negative 8. So when you type that in, 5 plus negative 8, it should give you negative 3. And that's what I write down here. Do not write plus a negative 3, just write negative 3. Now, my question for you guys, are we all awake? Hopefully so. Is to count how many terms there are. How many terms are there? I have them all in different colors. There are 4 terms. What is the highest degree? The degree is the highest exponent. So what's the highest exponent? Yeah, a 3. And then the leading coefficient is the number in front of the letter with the highest exponent. So I'm still looking at this yellow part, and it is a 2. That's why I've tried to color coordinate it all for you. Now, other coefficients, remember, that's other numbers in front of the letters. So that would be a 7. And we have a green 7 as well, but since we're making a list, you don't have to list it twice. And that's it, just 7 besides the leading coefficient of 2. So now it's time to go ahead and name the expression. So we name it 2 ways. The first way we name it is according to the degree. Yes, ma'am. Here? No, because negative 3 is a constant. Okay? Good question. So the question was, would we put negative 3 on the other coefficients? And you would not, because negative 3 is a constant. So to name it, the degree is 3. Looking up here with the exponent degree of 3, that is cubic. So I'm going to write cubic first. Now, sometimes they just ask you to classify it according to the degree. Other times, Your paper will ask you to classify it according to the number of terms. So how many terms did it have? You told me there was 4. So looking up here, how many terms are there? 4. And what's the name of that? Polynomial. Because remember, polynomial means many terms. So its complete specific name is cubic polynomial. Now, we're not done with that page, so don't turn it yet. We got to talk about this vertical format. Now, this is the one I don't like, but I'm not going to limit you on how you're going to write it. You can do it the vertical way or the horizontal way. But just hang in there with me for a second as I set it up for you. The vertical way, going back old school, like to first grade, we learned that 3 plus 4 is 7, correct? That is called the horizontal method. That's like what we just did. Okay? The vertical method back in first grade looked like this. 3 plus 4 equals 7. That's the vertical method. Was it any different? No. It was just wrote down differently. And that's going to be the same situation here. We're still going to do all of the same things. Now, when I do write down my vertical format, my first polynomial, I'm going to start with my highest exponent. So that way my answer will be in standard form. So my highest exponent is the 4. So I'm going to write down -2 v to the 4th. The next highest and then I've got that one done. The next highest exponent is 6v cubed. So I'm going to write that one down. 6, so it's a positive, 6v cubed. So I've got that one done. And then my last one is a positive 3v squared. I wrote all 3 of my first ones down. Notice they go in order 4, 3, 2. Then I have a plus sign that goes out in front, just like my old school ways. My plus sign went out in front. Now I'm going to draw my equal sign. And when I write this side, I have to write them in columns directly under what it is like. So the first thing is -4v to the 4th. I'm going to write that directly under the other one that was v to the 4th. Then the next one would be -4v cubed. So -4v cubed. That one's done. And then last but not least is this 4v squared. So positive 4v squared. Now we just add up and down. That's all we're doing. So when I look at this first one here, -2 plus -4 is a -6v to the 4th. Looking at the yellows, that's a +6 plus a -4 is a +2v to the 3rd. And then last but not least is my oranges. +3 plus a +4 is a +7v squared. So literally, you come up with the exact same answer. I just feel like it's a little more writing here. Okay? Let's look at the vertical format on this one. This is where it starts getting a little bit crazy. So remember when we highlighted these, that we had 2 of them that wasn't like anything else? That's going to be key here. So my highest exponent on this one is a 3. So we're going to have columns, and I'm going to make some columns up here just to make it a little nicer. Now you don't have to do this part. I'm going to erase them here in a second, but just so you can see it. So this first column is going to have exponents of 3, then 2, then 1, and then none. Just so we can keep it organized. Now, the first one is 2r cubed. I'm going to put that in the 3 column, so 2r cubed. The green one is a negative 1r, and that's got an exponent of a 1. So negative 1r goes in that column. And then my 5 goes in the last column, so that's in the none, so plus 5. Notice that there's not an exponent of a 2 in that problem, in that trinomial. That's why I left a hole there. Let's look at the next trinomial. We had a plus sign, first of all. We're going to put that plus sign in there. Now, it said 8r, so that means that's a positive 8r. And then you have this plus 7r squared, so it's got to go in the 2 column. So plus 7r squared. And then you have a negative 8 in your constant column. Notice we didn't have any yellows on this side over here. That's why there's nothing in that box. Now, if I erase my lines here so you can kind of see what it would look like without the lines. Kind of like the lines because it keeps things organized, but this is what it would look like without the lines. So if I add 2r cubed plus nothing, that gives me 2r cubed. Then I have 0 plus, because there was nothing there, so 0 plus 7r squared is a positive 7r squared. Next is negative 1 plus a positive 8 is a positive 7r. And then last is a 5 plus negative 8 is a negative 3. So again, I don't care which way you do it. You pick the way that works best for you. For me, it's the horizontal method because I can highlight my like terms. Now you can turn the page. All right, on the back side, we're subtracting polynomials. Now, just a reminder, you do not touch your variables or your exponents when adding or subtracting. You just do what it says to the coefficients, not the variables and not the exponents. Super important. Now, what I'm going to do is I'm not even going to teach you the vertical format because I don't like it. I'm just, and for time's sake, because my video is already 22 minutes, for time's sake, I'm going to just show you the horizontal method, okay? The first thing I want you guys to do is circle the minus sign that's between your two trinomials. Then I want you to pick up your yellow highlighter and highlight the first term. That first term is a 3. What is like the 3? If I look all the way through, it's going to be a 2. The next color, I don't care what color you pick up, I've got orange in my hand. I'm going to highlight the next term. That one's got an exponent of a 3. Is there anything else that's like that one? 4x cubed, yeah. And then my last one is a positive 7x. And the other thing that's like the positive 7x is the negative 1x. And remember, you can always write a 1 there to make it easier on yourself. When we write our answers, you must remember that you're going to be writing them in standard form. So you must start with your highest exponent. When you look through this list, what is the highest exponent? It's 3. So as I do that, my 3's are orange. Now, what I'm going to do on my pink paper is what you type in Desmos. My oranges say -2. Then there's a minus sign between my two trinomials. So there's my minus sign, and then it's a positive 4 equals. Type that in Desmos, and be very careful because negatives is what you guys usually struggle on. So what is -2 minus 4? -6. Now I have a -6x cubed for the first part of my answer. What is the next highest exponent when looking through here? Yeah, it's my greens. Let me get this to focus. There you go. It's 7x, so I've got a positive 7 at that, minus, and then a negative 1 equals. Type that in, Desmos. 7 minus negative 1, and what do you get? Type it in, Desmos. 7 minus negative 1 is 8. Is that a positive 8 or a negative 8? Positive, so that's where I get the plus sign from. So plus 8, and it's just got an x. Now my last thing is yellow, and on this pink little piece of paper, I can't use a yellow color, but because you can't see it. My first number is 3. My minus sign is in the middle, and then the other constant that's also yellow, focus, is a 2. So type that in, Desmos. 3 minus 2 gives you 1. Is that a positive 1 or a negative 1? Positive 1. So I'm going to write positive 1 in yellow. Questions on how to do that one? Again, I don't like the vertical format, and for time's sake, we're not going to do the vertical format. But it's super important that you type things in Desmos so you can see what the actual answer is. Looking at example 4. Example 4, I want you to go ahead and highlight your first term, which is an x. Is there anything like the x in the rest of the line? No plain x's. So now let's look at the negative 7. That's a different color. So is there anything else like the negative 7 all the way through the line? The 8. Then we have negative 2. Uh-oh. What just happened? Did I just lose my entire video? No. Okay. I don't know what happened. My computer went black. That went black. I don't know. No? All right. What is like negative 2x to the 4th? Yeah, negative 4x to the 4th. And then the one that doesn't have anything like it is this one right here. And I don't have a pink to be able to highlight that. So I want you to circle your minus sign that's between the two polynomials. Again, super important. What is your highest exponent when I look all the way through here? Because that's the one that you're going to start with. It is 4. So as I write that down, my coefficients are negative 2. Then I have a minus sign, and then negative 4. Type that in Desmos. Make sure you type it in Desmos because it's going to be maybe not what you expected it to be because we struggle with the negatives. Negative 2 minus negative 4 is what? It's positive 2. So now I have 2x to the 4th. So I've got the x to the 4th done. And if you want to mark them out like that, showing yourself that you've got them done, that's fine with me. Go right ahead. All right, the next highest exponent, as I look all the way through, this was a 1, that's none, that's none, that's a 3. So that's the next one I'm going to write. There's nothing else to combine it with, but watch. Everybody look up and watch. This is super important. How many x cubes are on this side? 0. Then we have a minus sign. And then we have this positive 8. Type that in, Desmos. 0 minus 8. You should get negative 8. Okay, so I've got negative 8x cubed. Okay, the next highest exponent, I'm done with that one now, is my yellow, and there's not a yellow over here, but there's an understood 1 right here. So take a minute, we have a 1, we have a minus sign, and there is not an x on this side, so that's 0. So what is 1 take away 0? 1. So that sign doesn't change, I can just carry it down. And that would be a positive 1x, or you can just write plus x. Last thing that we would do is our oranges, and that orange is constants, -7. The minus sign is part of the problem, and then it's an 8. So type that in Desmos, -7 minus 8. You should get -15. So I'm going to finish up my problem with -15. Questions on that? All right. Now, to kind of talk to you for just a split second on why that sign changed is because how some people teach this. So this is important if you're in academic lab. Some people teach it to distribute a negative to everything on after it. So kind of like this, if I had it -1 times 8 would have been -8. -1 times -4 is a positive 4x fourth. And -1 times positive 8x cubed would be a -8x cubed. Then you could have added it to the first one and combined like terms just like we did on the front page. I find most students make sign mistakes this way. That's why I didn't teach it to you that way. Okay? I find more luck with students if you just type it in Desmos, like what I showed you how to do here. Okay? Now, the last one is to model polynomials, and we're talking about perimeter. In order to calculate perimeter, all you have to do is add up all the sides. All the sides, every single one of them. All right? So in order to do that, I'm just going to start writing a big long line here. Okay? The first side I'm going to write down is a y. And then I have a plus sign because I'm adding it. The next side I'm going to write down is 4y plus 6. That's this one. And then I'm going to have a plus sign because I'm adding it. The next side I'm going to write down is 2y. So that's that one. Then the next, oh, I got a plus sign. Almost forgot. Then I have a y. Got a plus sign. Starting to run out of some colors. I never use red, but we're going to use red this time. Here's another y. And then my last one, oh, I forgot the plus sign. My last one is 3y. That's kind of hard to see. That's a plus sign, 6. So notice I kind of marked them out as I went around my figure. So that way I was sure I didn't miss a side. All right? Because the perimeter, you got to add all of the sides up. Now looking at this, we can highlight our like terms. Because all we're doing is adding. So I grabbed my yellow highlighter, and I'm going to highlight all of the plain y's. So y, 4y, positive 2y, positive y, positive y, and a positive 3y. The other thing I'm going to highlight is the positive 6 and the positive 6. So now we're just going to put together our like terms. Remember, in front of all the plain y's, there's an understood 1. So I just wrote those in. So we're going to do what it says. 1 plus 4 is 5. Plus 2 more, 7. Plus 1 more, plus 1 more, plus 3 more. So we have 12 y's. Again, since you're not in class, you're on the video, that was 1 plus 4 plus 2 plus 1 plus 1 plus 3, and it will equal 12. Now, looking at my oranges, my constants, a positive 6 plus 6 is a positive 12. Can I put these together? Absolutely not. So this is my final answer.